Good morning, people. So this is our 415 economic development. Today we are going to look at the big push models. Let me share my slides. In our last class, we discussed the issues of strategic complementarity, coordination failures, multiple equilibria, and now we're going to see an economic model that builds on these ideas. Okay, so let me go to my first slide. Yes, so the outline is this. First, we're going to discuss this idea of big push, then we will have this graphical representation of a simple model. Then there are some further issues to discuss in this context. So the question is simple: how can a country, can simply break out of the poverty trap, right? So how an economy that was stagnant for long centuries initiate modern growth? Does the prolonged stagnation affect the likelihood of a successful growth takeoff? Now, remember the Rostov idea. Remember Rostov's idea, right? So in Rostov's thinking, it is all linear. So if you save, eventually you realize the growth takeoff, right? Because now there's enough investment and sufficient investment. That investment allows you to transition to modern growth. But here we have a more complicated story, right? Because now it is not linear. So one interesting example is Argentina. Since the 19th century, this country exhibited some good prospects in terms of growth. Okay, but then later on, they exhibited relative decline. Their growth was not spectacular. There is actually a growth disaster, and the economy stagnated. And even today, Argentina faces certain obstacles for high growth rates in the long run. All right. So we want to understand not just the growth takeoff itself, but whether it is sustainable. Right. Now, the important economist today, the idea of big push is due to Rosenstein-Rodan. All right. And in his thinking, there is this circular causation. All right. So it is difficult to initiate modern growth or to initiate modernization in industry because no one wants to be the first industrialist. Why? Well, here there are strategic complementarities. That's the notion. So if I want to transition to modern technology, my return as a single entrepreneur depends on what other people will do. All right. So here we imagine a subsistence economy. Okay. In the subsistence economy, technologies are all primitive, low productivity technologies, and everybody is living close to a minimum standard of living, right? So incomes are very low, so there is no excess saving, excess investment opportunities, etc. All right, and if we assume also that, for simplicity, there is no exporting, so this economy is in some autarkic equilibrium, then one question is this: who will buy the goods that I produce? Right? Where is the demand? That's the question, because the economy is a subsistence economy. If as a single firm or as a single entrepreneur, if I transition to a new technology, I have to pay some costs. And if I produce more of these goods, how do I sell these goods? Because incomes are low, right? So profitability of an individual firm depends on what other firms will do. Why? Because if all the other firms also transit to new technology, then wages will also be higher, then demand will also be higher, right? So exactly as in our last class, exactly, remember that S-curve. So my return or my profitability as a single firm depends on what other firms will do. If the others also switch to new technology, then this will increase demand in the entire economy so that I can benefit from my investment into new technology. But if only I enter the market, only my firm transits to new technology, then demand is not enough. All right, is not enough for me to realize a return for this investment from this investment. All right, so obviously such a system creates multiple equilibria, right? Because once again, the profitability of one factory depends on whether another one opens, which in turn depends on its own potential profitability, and that in turn depends on the profitability of still other factories. All right, so that's the notion. Eventually, we have this coordination failure problem, right? Because if there is a mechanism that coordinates all of these firms such that we all agree and believe that if we all switch to new technology, we all benefit from this, then it will be all fine because we switch to this new technology and we benefit from it. But there is no such coordination mechanism. And furthermore, there is this externality thing, right? So I don't want to be the first one because when I enter the market, I realize some of these problems with the new technology. I have to train workers. So I basically pay some costs. And the other firms may benefit from these investments of the first firm. All right. So nobody wants to become the first, right? Because if somebody is going to pay these initial costs, costs about training workers, discovering the potential problems of the new technology, and all other related concerns, right? Then there is this tragedy of commons problem. So that's the notion then, right? Then if there is no coordination mechanism, nobody wants to be the first one so that economy never modernizes. No firm transits to new technology and the old system continues. So the economy continues to become a subsistence economy using only the primitive technologies with low productivity. There's no saving, no investment, and there is no demand. Okay, there's no higher demand to sustain higher profitability of modern technologies. So any questions so far? Because now I'm going to show you the graphical representation of the model. The idea is simple, right? Everybody gets that. It's a very, very simple idea. There is this circular causation. My profitability depends on others because all of our profitability levels as prospective entrepreneurs depend on the demand, right? If more factories or more firms transit to modern technology, then wages are increasing sufficiently, then this creates sufficient demand so that it becomes profitable. But if I only, if there's only one firm that enters that uses the modern technology, then there is not sufficient demand to cover the profitability, okay? To cover the costs for a profitable investment. Okay. So for the graphical representation of this model, we're gonna, of course, make some particular assumptions. First of all, we assume that labor is the only factor of production. All right, that's only for simplicity. You can introduce capital to the model. You can introduce land, other stuff, but labor just works for the simplest case. And the total supply is fixed. So imagine that population is fixed, and you know, you may imagine that everybody works. All right. Now, we discussed two types of sectors, modern and traditional. All right. In the traditional sector, or in the traditional technology, to be more specific, the wage is normalized to 1. All right, because productivity is low there, the wage is equal to 1. In the modern sector, or in the modern technology, wages are larger. Why? Because modern technologies are more productive. So if you are using a modern technology instead of a traditional technology, then you pay a higher wage because your firm is more productive. Okay. So here we have a large number of products in the economy. All right. And in the traditional sector that produces one of these goods, there's constant returns to scale. So if you have 5 workers, you have, let's say, 5 units of good. All right, because productivity is equal to 1. Right, so the production is linear. You have 5 workers, 5 units of output, 500 workers, 500 units of output, because wage is equal to 1, which is equal to productivity. All right. Now, in the modern sector, we have increasing returns to scale. All right. How does it be true? So here is the idea. So the economy is, so the modern technology is productive, more productive than the traditional technology, but for using it, if you want to use it, you pay some fixed costs. Okay. So that's it. After you cover the fixed costs, then you realize increasing returns. Okay. Now, importantly, this assumption is key. Any good in the economy can be produced with traditional modern technologies. All right. So let's say you want to produce coffee cups. You can use a modern technology, or you can use a traditional technology. If you want to produce laptop computers, you can use a modern technology or a primitive or traditional technology. Okay. We want to understand those switches. Now, here is a formulation. If you look at the graph, you see that the traditional technology has a slope which is equal to 1, right? Because, I mean, that's the notion, right? Wage is equal to 1. Productivity is equal to wage. In the modern technology, there is a fixed cost, F. Now, this fixed cost is paid in terms of labor. Imagine a situation like this. So if you want to use the modern technology, first you have to hire F workers. Those F workers just design the firm for you, design the technology for you. They produce nothing yet. Only if you hire the next worker, so that your demand for labor is larger than F, then you start producing. But the good thing is that you're producing more productively. Okay, because slope is 1 over C. C here is the marginal cost, and it is less than 1. So the slope of the modern technology, you know, the production function here is larger than 1. All right. So there is a trade-off. Either you're going to use the traditional technology with no fixed costs or no sunk costs. I mean, if you may imagine this as a sunk as well, or you first hire F workers, which is the fixed cost basically in terms of labor. Then, if you hire additional workers, then you start producing more productively. Okay. So in the modern sector, you may imagine a production function like this. Okay, the productivity, of course, is 1 over C. Okay, so if you use this mathematical formula, you can draw, as the orange line here. So other assumptions in terms of demand, we assume that an equal share of income is spent to all other products. Okay, so there are n products. So there is this national income Y, and that is spent equally. All right, so on the demand side, the consumers do not really differentiate from one good from the other. They all like all of these goods equally. All right. The economy is closed. And finally, we assume that the traditional sector is perfectly competitive. So the linear production function implies wages equal to 1, and this implies prices equal to 1. Okay, as you see, total revenue is equal to, so this is total profit. I'm sorry, total profit is equal to total revenue, which is P times Q, minus total cost, which is W times L. So since it is perfectly competitive, there is no excess profit, so price must be equal to 1. Okay, this is all very simple. In the modern sector, we're gonna assume that there's a monopoly firm. Okay, but this firm cannot charge a price larger than 1, right? Because there's a competitive pressure. Do you understand? So there's limit pricing here. So I want to produce with the new technology. I'm the only one now, but I should still charge the competitive price. Why? Because there's a competitive pressure. There are other firms that use the traditional technology and that they can sell the production, the good at price equal to 1. All right. Now, here's an important remark. The profitability of a modern technology firm in any one good depends on whether the other goods in the economy are produced with traditional or modern technologies. If more of the goods are produced by modern technology, then this creates larger demand for other goods through higher wages. The mechanism I just explained before. Now, we're interested in understanding how does profitability change depending on prevailing wages. Okay, and that obviously depends on what is the average wage paid in this economy, obviously. So now we can start our graphical analysis. So on the horizontal axis, you have labor. On the vertical axis, you have output. And now you see two technologies. The green one is the traditional technology. The slope is equal to 1. And the orange one is the modern technology. The slope is greater than 1, and there is this fixed labor cost here. All right. So here you see 2 points, point B and point A. What are these points? So in point A, be careful. If a modern firm enters, but there are traditional firms in the other sectors of the economy, the modern firm operates at point A. Why? Well, how do you understand this figure? So if a modern firm enters, but there are traditional firms in the other sectors of the economy, the modern firm operates at point A. Well, realize this difference, right? There's a difference there between the productivity levels of the two technologies. Now, in point B, if a modern firm enters, but there is no traditional firm in the economy, then the modern firm operates at point B. So the difference is that at point A, some other firms use traditional technologies, right? So this difference, so imagine the vertical outline here. So this part of the labor is employed by the modern technology. The remaining part is employed by traditional technologies. Here, all of the labor is employed by the modern technology firm. Okay, so the point of this slide is that both are possible. Okay, depending on whether traditional, the firms that use traditional technologies exist or do not exist. Okay, does everybody get this idea? So as long as there is a productive difference, it doesn't really a big issue whether there are some firms here, okay? Some firms using traditional technologies. However, when we introduce wages, the situation now is different. So this is case one, okay? This is case one. Now, in case one, W1, the wage in the modern sector, is greater than 1. Okay? But it is still, so if you imagine firm A, there is still profitability, right? The modern firm would find it profitable to operate at A, since its profit is strictly greater than 0 when the modern sector wage is equal to omega 1. So this difference now, the difference between point A and the blue dashed line, basically gives the profit. Okay? For this reason, it is profitable to operate at A, right? Now, this is true for all the other goods, okay? Because modern sector wage is W1. And what happens? All the firms industrialize, all switch to modern technology, right? Because even if others exist that use traditional technology, it is still profitable to switch to modern technology. Look at point A, right? So any point between point A and point B will be profitable. So firms will not stop at A. All switch to modern technology. Okay, all firms will switch to modern technology so that the entire labor endowment for that sector will be employed by the modern technology firms. Okay? So what do we learn here? Well, there is no need for a big push. Okay? Because modern sector wages are sufficiently low. Okay? This blue dashed line, the slope of this blue dashed line is sufficiently low. So if a firm finds it profitable to switch to new technology, all the other firms also find it profitable to switch to new technology. Okay. Now, in case two, the situation is different. Why? Because in case two, modern sector wages are larger, okay? So if a firm enters the market, only a firm enters the market at point A, it is not profitable, right? If only one firm enters and there are other firms that use traditional technology in that sector, okay, it is not profitable for just one firm. When does it become profitable? Well, if all firms enter. When all firms enter, point B is equilibrium for all firms, right? So then there are two equilibria. One is C. Everybody is using the traditional technology because as standalone firms, it is never profitable, so that they cannot coordinate themselves all together to enter into modern sector. All right. Or if they coordinate, if they coordinate to enter with modern technology, they all go to B, and B is profitable for all of them. Okay. So what determines this is that wage is larger but not too large. Okay, larger than W1 but not too large, so that point B, when every firm in the sector transits to new technology, this creates higher demand and then therefore higher profitability for all of them. But there is no obvious coordination mechanism, so there are two equilibria. Now you see the coordination problem and multiple equilibria, right? There's an equilibrium at point C, where all firms in the sector use the traditional technology, and point B, where all firms use modern technology. Okay. So there is a need for a big push. Okay. So if you find some mechanism to increase profitability for all the firms, then you create the big push, let's say through demand, then they all transit to new technology. Now, in the third case, modern technology wage, or the modern sector wage, is too high. As you see, point B, even point B is not profitable. Okay? Even point B is not profitable. What is point B? Point B is the point where all the firms switch to new technology. All right? So basically here, the economy can never industrialize because switch to new technology is too costly. And no externality, no demand channel would create higher enough profitability for make this investment true. All right. So in that case, the equilibrium is point C, because again, even if all firms enter with the modern technology, there's no profitability from doing that. Okay. So that's the idea. That's the idea of big push. There's coordination. There's first strategic complementarities through the demand channel. Then there's coordination failure among firms in terms of switch to new technology. Then there's multiple equilibria for certain ranges of wages. Now let me stop here and answer your questions if you have. We have about 2 minutes. Then after the break, we're going to continue. Any questions?
I have a question, but it's not related with the cases.
Then you're gonna ask it later on after at the end of the class.
Okay.
Any questions related with this graphical representation of the model? Okay, then let's take another break. Now I would need about 15 minutes for conversion. So let's meet at 10:45. Okay?
Okay.
10:45.